Okay, guys, we're going to start chapter 3 here. And in chapter 3, we're going to talk about statistics for describing, exploring, and comparing data. And where are we in this little arrow? So we've talked about in the very first chapter collecting data, sampling, abuses of statistics, and so forth. And then in chapter 2, we just talked about presenting data, different graphs, histograms, frequency distribution tables, those kind of things. And now in chapter 3, we're going to look into measures of central tendency and variability. You're thinking, wait, are we 3/4 of the way through the semester, but only in our third week? No, there's quite a few chapters in between here as we look at approaching data analysis, right? So we're going to look at sort of the second part of descriptive statistics, and that is measures of central tendency, which is how do I measure the middle of my data, and variability. How do I measure variability? Okay. One thing to note for this section, 3.2, we're just going to focus on measures of the center. So there are 4 measures of the center: mean, median, mode, and mid-range, that I'm going to expose you guys to. And the parable that I want you to think about is, the proverb: let the wise hear and increase in learning, and the one who understands obtain guidance. In other words, wise people never stop learning. You're going to see some terms, some calculations here that are very simple. And then this is usually the chapter where we now start differentiating from stuff you've seen before and stuff you might not have seen before. And that means you need to continue learning, be a wise person, and never stop learning. Okay? So, measures of central tendency. We're going to go through all 4 of these, and then at the end, I'm going to show you, compare all of them, and then show you why these 4 are not enough to do a proper data analysis. Okay? A measure of the center is the value of the center or middle of the data. We have these 4: mean, median, mode, and mid-range. You probably heard of the first 3. The 4th one isn't used as much, and I'll share with you guys why that's the case. Let's jump right in. Measures of the center. The first one is the mean, or the arithmetic mean, or the average. This is the one you guys are most likely familiar with. The mean of a data set is found by adding the data values and dividing the total by the number of data values. So here we have some data. If we take all of these data points, add them all up, and divide by the number of data points, looks like there's 7 of these, 7 numbers. So here we have me adding all of them up, dividing by 7. You get 105 divided by 7. The arithmetic average is 15 to this data set. Okay, so that's the arithmetic average, or the mean. Before we go on to describe how we write the mean using special notation, here is the page for the special notation. So this first letter right here is a Greek capital letter sigma. Say sigma once. I know you're probably by yourself listening to this anyway. So sigma, that denotes the addition of a whole bunch of values. And x is just the variable used to represent the individual data values. And then n represents the number of data values in a sample, little n, and then capital N represents the number of data values in the population. So these last 3 are probably ones you understand, familiar with, but this one I need to expose you guys to a little bit more, the sigma. And again, since I know that you're probably by yourself listening to this, just scream out the letter sigma. Sigma. Let's talk about that sigma. That's the so how do we calculate the mean? Another way of writing the mean is sum up of all of the x values, the numbers, the data points. That's what this numerator portion means. Sum of, so sigma means sum of all of the x values. And then n means here the number of total values. So divide by the total number of values. Add each of the data values, and then divide by the total number of data values. That is how we calculate the mean. Now there's a difference when we calculate the mean for a sample and for the population. For the sample, when you don't have all of your values, you're taking a sample, we usually use the x-bar notation. So this might be your first exposure to some new notation. X-bar means that you're looking for the mean, or you found the mean of a sample. okay? And in that case, we use little n. So x bar refers to sample mean, and little n refers to sample total number of values, or the total number of values in the sample. If we're going to take the entire population that we're interested in, and we have access to actually counting or calculating, taking the data points and adding them all up together, and then dividing by the total number of data points in our population, then the mean of the population is denoted by this Greek letter mu. That's Greek letter mu, usually used for micro in chemistry and physics as an abbreviation. And then in that case, we use capital N for the total number of values in the population. Okay, mu and big N you should associate with the whole population. And that's different ways of writing the mean, pertaining to the sample and pertaining to the population. I have a step-by-step process of how to calculate the mean on a calculator. Suppose you have 20, 30, 50 data points. You're not going to be adding all of those up on a calculator. Why not just enter the data points, click a couple buttons, and then you're going to, the calculator is going to spit out for you what the average is, okay? Please do go through this so you are able to find what the average is. Use maybe something that is very short, 3 or 4 data points, and then confirm that you're getting the right answer. After a couple of these, you'll figure out that, man, I really need to hug my calculator more often, because you'll see how these calculations get very, very heavy and very just cumbersome without a calculator. There's a way to clear also your data set. Press stats, press the number 4, clear list, and then clear list 1, list 2, list 3. The way to access list 1 is to press second and then find the list 1 button, which is usually the number 1 on a TI-83, 84. Okay, so that's some calculator references. The next one is the median. That's the middle value. So if you take your data and write it in ascending or descending values, then the one in the middle will be the median. So here we have some data. It's the same data. Now we rewrote that data in least to greatest, and the middle value ended up being 15. So that is our median. There's an odd number of values here, and so we have only one value for the median. Sometimes you'll see that it's denoted by x tilde. This is a tilde above the x. So x tilde is the median sometimes. That's the symbol used for it. And so you're probably asking, wait, what do I do when I have an even number of values? If I have an even number of values, the middle would be 2 values. And so since you have 2 values in the middle, how do I find a median of that? Well, I'd add those and find the average. Add 58 plus 83, and then divide by the 2 values. You get 70.5, and that would be considered the median. Or that's how you calculate the median with an even number of values. Please note that this number 70.5 is not a number in this data set. Okay, so the median can be a number that's not even part of your data set, even though it's considered the middle of your data values, right? The middle number of your data values. This number is not part of my data set. Okay, so that's the median. Let's compare the mean and the median. They're both measures of the center. And so I'd like you to stop this video and just think about how you'd finish the sentence. Although both tell you something about the center of the data set, the median, just think about it, pause. Again, please pause the video and just think about it for 10 seconds. Okay, the median is not affected by an extreme value. That's the bottom line. Let's compare that with this example here. In this first case, take a look. I have the number of values 1, 2, 3, 4, 5. If I take the average, the mean, then the mean, take all those numbers, add them up, you get 15, divided by 5, and you get 3. Okay, so that's the mean here, which is also the median, right? If I take all these numbers, what's the middle value? The middle value is 3. Okay. Then I go over to this side. If I take all these values, now I have 1, 2, 3, 4, 10. If I add all of these up, the average, the mean, is going to be 4. what is the median? The median among these odd number of values is still 3, right? So the median didn't change. What changed was the mean, the average, because the average includes all of the data points, and therefore if there are outliers, something really, really far away, they will affect the mean, whereas the median is not affected as much. So take note of that. The median is affected by outliers. The mean is affected by outliers. The median is not. The mean is affected by outliers, and the median is not. Significance of the mean, or the median, excuse me. Even though the mean, the average, is the most common measure for the central tendency, the median is used where a statistical measure makes a definitive social impact. And there's a lot of different places where we use median, the median house price, the median income, the median age, because there are outliers, right? There's billionaires, there's people that are really old or really young. There's house prices that are really, pockets where there's $1 million homes, and then pockets where there are, really cheap homes. And here's a really quick example. If I take these home prices right here in this list, if I take the average of them, notice that there are a couple of outliers. The mean would be this one right here, right? And the median would be 451. They're already listed from least to greatest. So 451 would be the middle value here. Now, think about this. If you're a real estate agent, or if you're a buyer, if you're a seller, which one of these would you actually like to report, right? Well, if somebody's claiming that you've priced your house, if you're the seller, and somebody's claiming that you've priced your house too high, you probably want to refer to this number, right? Well, wait. The mean is 584, right? But if you are the buyer, you want to know what the median price is in that area, because you're not interested in the outliers, right? And so that's why Zillow, if you open that app, will actually tell you what is the median house price. In this case, this is more valuable information, right? This would be misleading information for the average house, for instance, or the middle cost of a house in that particular neighborhood. So keep this in mind. Again, the mean is affected by outliers. The median is not affected. Here's another one. Interesting thing about the median. The median can be used in situations where we cannot get a proper measurement, but can only rank data in order. So for instance, an example here, if we arrange workers in order of their performance, a worker in the middle would literally represent the median performance, right? I don't have numbers to report back for people's performance, but a person, when they're listed from least to greatest, the person in the middle would be median performance, or represent median performance. So we can locate the median by selecting a middle value, even if we can't perform an actual calculation. Notice that. So all the data values can be put in order from least to greatest, right? One way or another, whatever the data type it is. But you can't always do calculations with them. But you can find the middle, the median. Okay, on to number 3, mode, aka most occurring value. So the mode is the value that occurs the most frequently. And please note, for instance, in this data set, what's the number that occurs most frequently? Looks like 53 occurs several times here, 4 times. Please note that the data could be bimodal. The prefix bi means 2. There could be 2 frequently occurring values. It could be multimodal, meaning there are several, more than 2. And some people also classify that there is no mode when all of the values have the same amount of occurrences. Okay, let's take a look at some examples here. So the very first one, what is the mode? The mode is 5. Most frequently occurring number in the data set was 5, so that's the mode. In this example here, notice that 2 shows up 3 times and 6 shows up 3 times. So this would be considered bimodal, where our modes would be 2 and 6. In this case right here, where all the numbers occur exactly the same number of times, you have no mode, right? There isn't a most frequently occurring value. And then when they are the same amount and there's multiple of them, more than 2, we would say classify this as multimodal. 4 shows up twice, 6 shows up twice, and 12 shows up twice. That's a multimodal data set. Okay, hopefully that's a little bit more clear and you have some more intuition. The last one here is mid-range. This one isn't used as much because take a look at the formula. The formula incorporates the maximum value and the minimum value. Well, can you imagine a data set where you have a maximum value that's a really, really far outlier and a minimum value that's a really, really far outlier? You're taking the average of two outliers. So that is another measurement of the middle, but because it incorporates using specifically the outliers, potentially the outliers, not all data sets necessarily have outliers. This is very just vague, or not, I should say, very general measurement of the middle. It's actually a mid-range. We'll talk about range in the next section. But mid-range, take your range and find the middle of your range. So your maximum and your minimum give you a span of values, if you will, and you're finding the average of your range, the middle of the range. So this is how you calculate the mid-range, maximum plus minimum divided by 2. In this case, this is 15. Again, this is a measurement of the middle. That's what mid-range is. It's not used very often because of this issue that outliers really skew the measurement or the middle. So here's another example. Can you pause the video here right now and try finding, just test yourself. How much do you remember right now? It's very important. The mean, median, mode, and mid-range. Find that for this data set. Again, these are just house prices. Find the mean house price. Find the median house price. Find the mode, if there is one, and find the mid-range. Pause the video and try it. Okay, so hopefully you paused the video, and here are the numbers that you should have gotten. Take 3 million, if that's what you get when you add up all of these numbers, and divide by 5. There's 5 numbers, and you get 600,000. The median is 300,000. The mode is 100,000, and the mid-range is 1,050,000. Do you see how the mean and the mid-range are very much affected by outliers? This right here, right? That's the 2 million. That's affecting this mean and this mid-range as well. The span of values here is quite large, between 2 million and 100,000. Okay, so that's good practice. Really quick tip for rounding rule for mean and median. You always want to go for one more decimal place than there is in the set of values. So suppose we have money spent at a convenience store, right? What's the furthest decimal point that we have? Well, we have the tenths, and then we have the hundreds. Here we have the tenths, and then hundreds, tenths, and then hundreds, tenths, and then tenths, and then hundreds. So the furthest that any one of these data points goes out is the hundreds place. So if I want to find the average spent in a convenience store based on this data, I would add up all the values, get 44.11, divide by 7 values, and then what do I round to? Well, here is the hundreds place. We want to round to one more place than the hundreds place. Just give your reader a little bit more information than reporting the entire number. So we would round to 6.301 because the 4 is, or the number after the hundreds place, the thousands place, it's the number after that is 4 or less. If it was 5 or more, then I'd put a 2 here for my rounding. Okay, so I hope that makes sense. Round to one more decimal place than there is in the data set. Well, what if I don't have the raw data points? What can I do? What if I have a frequency distribution table? Well, here's the logic behind using class midpoints. It says here, use class midpoints as an estimate for the mean of each class of data points. So here's the problem. It says weight loss. Let's say this is 0 to 4 pounds. And I have 3 people lost 0 to 4 pounds. Okay? So here's the issue. I can't really find the average because I don't know how many of these 3 people lost 2 pounds or how many of these people lost 3 pounds, or, the range in this class is 0 to 4. But it is reasonable for me to take the middle value, the midpoint between 0 and 4, which would be 2, and say, well, I'm going to use the middle value and multiply it by 3. So 2 times 3. Here the midpoint would be what? 7. 7 times 5, right? So we're replacing. We don't know how many 1s, 2s, 3s, and 4s and 0s there are, but we're going to use the middle value and say we have 3 2s. We have 5 7s. We have 4 12s. And that would be a measure of the middle that we would use to find the average. The formula here, sum of, take the frequency count, so that would be 3 in this case, and then the midpoint, x here, which would be 2 in the first class, and divide by the sum of the frequencies. Remember, this frequency column here is a tally of all of the different data points put into different classes. So there's a total of 3 plus 5 plus 4 plus 1 plus 0 people or data points. So here's the actual calculation. If you find the midpoints, add the two numbers, 0, 4 divided by 2, 5, 9 divided by 2, 10, 14 divided by 2. You get the midpoints here in the middle column. And so what we're doing is we're going to say we have 3 of these, we have 5 of these, we have 4 of 12s, right? 5 of 7s, 3 of the 2s. And that's what this calculation is doing. We're taking 2 times 3, which is the same thing as adding 2 plus 2 plus 2 3 times, right? So we don't need to necessarily do multiplication, but it makes for less writing. So we get that value, 106 divided by 13, and then we have 8.1538. It's around that number, right? And so I take a look at my data points, my midpoints around to just the ones place, so I'd round to one extra place. Maybe I'd write down 8.2 here for the tenths place. Please note x is the class midpoint, f is the frequency, and so the sum of the frequencies is the total number in your sample. Again, please hug your calculator. Your calculator can do this. What you're going to do is enter the midpoints, so you're going to have to calculate those. Find the midpoints into list 1, find the frequencies and put those in list 2. Press statistics, cursor over to calculate one variable statistics, and then instead of just writing one list, list 1, do 2 lists, list 1 and list 2. Okay? That's how to calculate that on the calculator. The weighted mean. Think about this again. Pause the video and think, if you average 80 on the first 3 exams, and then you get 100 on the 4th exam, is your new exam average 90? This is a mistake that is often made. So pause the video for 10 seconds and just think about how to calculate this weighted mean correctly. Okay? Again, I hope that you pause this. It's very important that you think for yourself. So if you took and added 80 plus 100, you're actually taking the average of 2 tests. So this would be the incorrect way to calculate this. You'd think that it would be 90, but it's not. The correct way, because there are 4 exams total, you have 80s and you have 100 divided by 4. So that equals 85, which is the correct percentage. A lot of students think, oh wait, the computer's not calculating my grade correctly. And this is how I actually calculate your grade. I take the weight of that category, the tests or the quizzes or the homework, and multiply by how many points there are there, right? And then divide by the sum of the weights. And I think the syllabus for our class is a little bit different, but just to give you some idea. So these are the weights, 20% for homework, 56% for exams, and 24% for final. And that is the way that I'd be able to calculate your grade, or you can calculate your grade to make sure that Canvas is calculating it correctly. Okay, to compare all these, we're in the home stretch for this section. Advantages and disadvantages. Really quickly go through those. How often are these used? The mean, that's the most familiar one. We used a lot. The median is used commonly. The mode, sometimes, just to point out, look, here's the most frequent occurring data value, right? And the mid-range rarely is being used, again, because it's basically an average of the range, or an average of 2 outliers, potentially. Next question, does it take every value in the data set into account? The only one that does is the average, the mean. The other ones, the median does not take into account all of the other data points. It's just one value. The mode only takes into account one, and mid-range takes into account two values, the maximum and the minimum, but it doesn't take into account all of the values, right? Which ones are affected by extreme values? The mean is affected by extreme values. The median and the mode are not, because they're the middle and the most frequently occurring. And the mid-range is also affected by outliers because it's basically the average of the outliers or potential outliers. I need to expose you guys to some vocabulary and connect now the mean, median, mode to a distribution, to a shape of the graph. So we have symmetric as skewed. Symmetric and skewed. Data is symmetric if the left half of its histogram is roughly a mirror image of the right half. And it's skewed if it is not symmetric, if it extends more to one side than the other. Let me give you some examples here. So here's the interesting thing about the symmetric, or the bell curve, which you've probably heard. The middle value in the bell curve, remember the values along the x-axis would be the values of your data points, and the frequency would be the y-axis. So the most frequently occurring, the mode, the mean, the arithmetic average, right, because it's literally the middle, and the median, which is the middle value. So the mean is a weighted, right? So it takes into account this weight and this weight. Well, because it's right in the middle, this weight equals this weight, and therefore your middle is literally the same thing as your mean or the median. And really quick data set here, 2, 3, 3, 4, 4, 4, 5, 5, and 6. If I find the median is the middle value, which is 4. The mode most frequently occurring also is 4. The mean, if you add them all up and divide by the number of values, is also 4. The frequencies are 1, 2, 3, 2, 1 for those for that data set. And again, notice all these three, mean, median, mode, are all the same value for symmetric. Okay. Symmetric or skewed, compare them. Well, if it's skewed left, and the way to remember this, by the way, when we say skewed left, just remember that the tail end is on the left side, and you can name it skewed left. Or the tail end is on the right side, and it's skewed right. Okay? So comparing these now, take a look. When there is a skewed, when your distribution is skewed, your frequencies are very, very small. Then, they get larger, and then they die off again relatively quickly, a lot quicker than they were actually rising. Then the mode, the most frequently occurring, which is highest frequency, the highest point in our histogram, would be to the right of the other two. The median is the middle value, and the mean is being pulled even more by these outliers to the left, right? So the mean is not, all three of these would not be aligned. They would be written in this order. And if you're for skewed right, if the tail end is on the right side, there's a mirror image of the order. Mode, highest frequency, then median, middle value, and then mean is also a measure of the center, but this one takes into account all of the values, so it's being pulled by this tail, by this number of values that are very, very low frequencies, but there's many of them. Okay, so that's a comparison between symmetric and skewed distributions and the mode, mean, and the median. Finally, consider these two data sets. If I gave you 36, 40, and 41, and asked you to find the average, the arithmetic average, add them all up, divide by 3, and you get the number 39. What's the median? The median is the middle value, which is 40, when the data set is written from least to greatest to least. If I take another data set number 2, and we have a 2, 40, and 75. Notice the difference in the span or the range of the data set. The average, if you take them up and add them all together and divide by 3, is still 39. And the median is still the same, it's 40. But do you see the difference between these two? There is a difference between them, right? Even though the middle values are the same, the span of the values are different. And so that's what we need to talk about in the next section. Here's one last example to bring it home. That idea that we can't use just the mean, median, mode, and mid-range to analyze a data set. So suppose you go into a bank and there's a number of minutes that you have to wait to be helped. And so there's two banks, Green Valley and Big Spenders Bank, GVB and BCB. And recorded here in dark blue and light blue are the number of minutes that a person would have to wait to be served. If you actually take the dark blue and find the mean, median, mode, and mid-range, do the same thing for the light blue, you'll get exactly the same numbers. That's crazy. And so just taking a look at this Green Valley Bank and Big Spenders Bank, you would conclude, just looking at the middle values, the measures of central tendency, you would say it doesn't matter actually which bank that I go to. The average waiting time is the same, however you calculate it. But if you take a look at the data sets are not exactly the same. Here's a dot plot that we talked about in chapter 2. Here's a dot plot showing the span of my data values, or the range of my data values. Well, if you take a look at this, looks like the top bank here, the Green Valley Bank, is more consistent with their wait times. Whereas Big Spenders Bank is all over the board, all over the from really, really, really small values to 10 minutes waiting in line, right? And so even though the measures of the middle are exactly the same, there's a different measurement, a measurement of how they are dispersed is another calculation that we need to take a look into. So how do we differentiate this data? We need measures that describe how the data is dispersed, not just the center or the centers of the data set, but how they are dispersed. And that's what I'm going to go through in the next section. Go through range, variance, standard deviation. Both of these are very similar, and then a coefficient of variation at the end. I'm sorry, in the English it works out very well. The 4 M's of the middle, mean, mode, median, and mid-range, it's not the same thing for variation. I wish they were all V's or, measures of spread, how the data is spread out. All of these would be S's, but that's not the case. So take a moment right now, take a break, and then do some homework exercises for section 3.2 to make sure the information solidifies. And then we'll move on to this next video.